So I think in CS1, when we covered the Python language, we actually mentioned about the inheritance and also about the derived class. So a derived class is a class that is derived from another class. That's a This is a kind of funny definition. So derived class is a derived from another class. Okay. Uh, that class is called the base class. Okay. Um, so first thing, any class may serve as base class. Um, so now, what is the derived class? Okay. So suppose we have a class. I could define a class called student. Okay. So then we can actually define the attribute for the student, right? So we can define all the field variables for the student. So like a student last name, first name, and what else you think should be used as a field available? Student ID. What else? Okay, I see. Should you be presenting? Oh, okay, sorry. I think I forgot to. Okay, I apologize for this.
It's okay. I would have forgotten to.
Yeah, I think one thing is I just forgot this. The other thing is it used to have actually, it's just a language. They describe what the button is, but now there's no actual words. There's no wording. Just as an icon. So okay, so we're talking about a derived class, which is actually defined, um, you know, as a subclass of something called a base class. You know, I'm actually trying to talk about what's the background between the base class and derived class. Okay. So now so let's say we define a class called a student. So we know that students should have some field variables, that the attributes that describe the student itself. So the field variables could be last name, first name, student ID, and what else you think we should include as a field variable for student? Major, right? Anything else? And then we have a whole bunch of methods. Okay, so these are the field variable. Then we can define a whole bunch of methods, like you know, register a class, take a class. Okay, so we can define various different methods. Okay. However, in certain cases, we probably want to define a special type of class, okay, a special group of students. For example, we want to define a class called computer science student or CIS student. Maybe math. Okay. Now, if we want to do this, then we can actually define a class called CS student, right? And then we can include last name, first name, student ID, major. Yeah, major is CS. So it's, and then we have probably like a concentration, you have a cybersecurity concentration or something like this. So, and also CIS student and a math student. So now in this case, we can define a CS student and which include all this, right? But Java allows us to define CS student as a derived student of a student, a derived student of the base class called student. Now, the reason behind this is we find out every field variables, last name, first name, student ID, major, also applies to CS student, right? Because CS student is a student. Okay, CS student is a student. Now, this means everything we defined for student also apply for CS student. Okay, so every field variable also apply to the CS student. Okay, however, CS student may have more field variable, which may not be able to apply to the general student. Okay, so for example, if we say cybersecurity concentration, this is actually a particular field variable, applies only to CIS student, but not to the general student. Okay, if the general student, you don't know the major, right? So maybe you know the major, but sometimes the major is math, sometimes is a biology. So in that case, there's no such a concentration called cybersecurity for biology student, for math student, right? So in that case, we can define CS student as a subclass of student or derived class of a student. In that case, student is called a base class and the CS student is called a derived class. Now, the relationship between derived class and the base student is, a derived class is a base student, but I'm sorry, derived class is a base class, but the opposite may not be true. Okay. Now there's a lot of kind of relationship like this. So for example, we define a vehicle. Oh, I have a difficulty pronounce this. And then a vehicle may have, it's a very general term, right? It's everything just moves, a vehicle. Then we can say define a class called a car. Okay. And then we can define a class called SUV or pickup truck. Okay. So we can always do this. So in that case, we can define a vehicle as So we can define a vehicle as a base class, and the cars, SUV, pickup as a subclass. Okay. So now, what's the relationship? A car is a vehicle, SUV is a vehicle, pickup is a vehicle, but a vehicle may not be necessarily be a SUV. It could be something else. So that means all the attributes, all the field variables defined for vehicle also applies to car, also applies to SUV. But there are some special variables only defined for SUV. For example, for SUV, you may say 4x4 or crossover, something like this. Pickup, we can say, besides all the actual characteristics defined for vehicle, pickup may have some special field variables like a half cab or full cab or something like this. So that's basically defines the class, and it's a derived class. Okay, so the relationship is car, a subclass car is a vehicle, right? So that's a relationship. Now, Java allow us to define a derived class. Okay, now a derived class is said to inherit the property of base class, and this is a concept called inheritance. Of course, that's the case, right? Because every actual attributes in the base class also applies to the subclass, the derived class. So of course, derived class can inherit everything defined in the base class. Now, once you do this, then you don't have to define all these variables in the derived class. You can directly use the variables in the base class. Okay. Now the syntax is pretty simple. So if you define a class called derived class, and the base class is this, and then you're going to define a class, say class derived class extends base class. Okay. So that's a syntax. The syntax is pretty straightforward. And then we need to study how you're going to use the base class and how we can use the derived class. This is going to save us some time, because when you define the derived class, you don't have to define everything. If something is already defined in the base class, we can directly use them instead of actually redefined in the derived class. You don't have to, and you can use them. But in the derived class, you only define the variables that's dedicated to that class, okay, to that particular class. Now here are the inheritance scenarios. There are two scenarios. Now one, a derived class can serve as a base class for another class. Okay, so you basically can create a tree of this. Okay, so that's a base class, and then you can define a couple of derived class. Now this derived class can also serve as a base class for some other classes, and this class can serve as a base class for other classes. So these inheritance, you can build a tree structure for the inheritance. Okay. Yes? Do you have any questions? Okay. Um, I thought someone just raised a hand. Now here's the example. So we can define a base class called a person. That's a very generic class, right? And then we can define a derived class, student. Okay, professor. And I can even define like something like engineer or designer. So these can be defined as derived class. Okay, so student is a person, professor is a person, engineer is a person, designer is a person. Okay, and then we can define a special type of student. Okay, so we say CS student, math student, and for professor we can say CS professor. We can define a whole bunch of derived class. Okay, so so this basically says a student is a derived class for person, but a student is a base class for CS student, right? So it can serve as base class for other classes, but it's itself is a derived class. And also a class can serve as a base class for multiple derived class. Okay, so you can actually have a multiple, derived class. So for example, person can be served as a base class for a couple of derived class. However, Java um, does not allow to have multiple base class. Okay. Now, this is actually the restriction. So that means a student can be a derived class for a person, right? Okay. Now, student should have only one base class. Okay. Student cannot have more than one base classes. Okay. Base class. Now that's basically for Java. That's that's not necessarily true for other language. Depend on the language. Some other language also allows to have a multiple base classes. This the multiple actually base class also makes sense in some case. For example, a student, say, could be derived from a person, but a student also can be derived from, let's see, um, another from another. Now this is probably not um, this is probably not a good example for a multiple inheritance. Okay, multi inheritance. But in some cases, it actually makes sense. Okay. Let's see. Student is a person. A student is okay. It could be like let's say engineer. So engineer could be a person, but engineer could also inherits the um, even like a student. Okay. Okay. So the engineer could be a student. Okay, it could be a student of, uh, and or could be a person. So he could actually serve as a student somewhere. He is actually working as an engineer, but he is also a student. But he is also a person. So you can actually have a multiple inheritance, okay, which makes sense in our real life, right? So you can inherit you can inherit from different sources, okay. But the Java actually does not support this multiple inheritance. Just keep that in mind. Java does not support it. Okay. Java doesn't support it. Now to better understand what does inheritance works, let's actually take a look at the bank account class again. Okay. So in the bank account, remember that we create a class called a bank account. So when we use the bank account, we're going to say bank account. So we can define an instance of bank account. So my account, say my checking account. Okay. I call it a default in constructor. So that's a constructor call. However, in some case, we just want to define a different type of bank account instead of just say my checking account, my savings account. But we still don't know what's the difference between checking account and savings account, right? So, but if we actually using the name called my checking account, but it's still a bank account. So there's a account balance and account owner and account ID. And then I can define bank account, my savings account. And my savings account has a bank balance, my account ID, and account owner. It's the same. My checking account, my savings account, they're different account, but they actually contains the same characteristics. They contains the same values, same actually attributes. Now I want to actually define a different type of account. Now how the different type of account gonna gonna be different? So let's say I have a bank account. So then I can make another class, derived class called a checking account. And a savings account. Now, of course, the bank account has account balance, account owner, and account ID, right? Now, checking account is derived class. It's a derived class of bank account. So checking account inherits the balance, inherits the account owner, inherits the account ID. But what's special about the checking account? Shall we define a dedicated field variable for checking account? And what's special about the savings account? Can we introduce any new field variable which applies only to the savings account? Now, if you put the money in the savings account, mostly you're going to earn some interest, right? Typically savings account comes with an interest rate. Even though at this moment the interest rate is pretty low, it's almost nothing. But you have interest rate, right? So you may actually, savings account, you may actually have a field variable called interest rate. Now, typically not for the checking account. So for checking account, you don't gain any interest. When you put the $1,000 in your checking account, now the only benefit of a checking account is you can write a check, you can withdraw a check, you can deposit a check into the checking account. So you can actually manage your balance. Okay. But you don't actually earn any interest typically. However, checking account has a limitation. In many cases, a bank only allows you to have a limited number of transactions. So for example, you can deposit the money, you can withdraw the money, but each actual action is a transaction. Deposit is one transaction. Withdraw is a one transaction. Transfer money from one account, your account to another account is also a transaction, right? So, but checking account has a limitation. Sometimes they only allows you to have, for example, uh, 10, 5 transactions total, 5 free transactions. But if you actually reach the limitation, so you reach the 5 transactions in a year, then they start to charge you the money for each transaction. So maybe the transaction fee gonna be like $20. So for when you transfer the money to another account, I charge you $20 because you have reached the limitation of the free transactions. So in checking account may have a transaction count. Okay. So you want to define 2 different accounts to make them different. Okay. Let's actually take a look at the example. Okay, so let's see. So we have a bank account. That's something we just worked on. So I think we separate the bank account and also my account main. So I put the main method in my account main. Okay. So the bank account basically defines a bank account. Okay. Now we can actually define another account. It's called checking account. Checking account .java. Okay. Okay. Now for the checking account, okay, so I want to actually define the checking account as this. So let's see, public class checking account. Now, if you want to define the checking account as a derived class of the bank account, so I'm gonna say checking account extends bank account. This way, I'm gonna inherit most of the, the fields and also the public methods of the checking account, of the bank account. However, so in the checking account, I don't have to define a balance because balance is already defined in the bank account, right? So what I do is I define private transaction count. Now also, I want to define the limitations for the free transactions. Now in that case, I can define private, I can define as a statical, the constant, So I put the final, and it's an integer. I can define as private final integer int, but it's a statical, and I say free transactions, and I put a 5. Okay. So that's the total number of transactions, and I allow to put in there. Now, once the customer reaches the you know the free transaction count, which is 5, and then I'm going to charge the fee. So I'm going to define another private static statical final double, which is amount. Put the transaction fee like a $5. Do that, right? Now here are a couple of things we need to resolve. Okay. Now, once we define a class called checking account, we can inherit most of the methods, the variables from the base class. So that's the reason why we did not define balance. We did not define account owner because it's already defined in the base class. Now, when we actually define the checking account, and the next thing what we do is for each class, we need to define a special type of method, right? What is this called? We need to define constructors, right? Okay. So let's say public constructor, and we're going to say checking. Constructor name should be the same as a class name. And then we want to define a default constructor. Okay. Okay. Now, what is the default constructor supposed to do? Let's take a look at the bank account. What's the default constructor for bank account? So in the bank account, we basically call another constructor, which has 0, 0 as a balance, initial amount, and the owner as a John Doe, right? So we can actually define, let's say, first we can define the, let's define the account like this, say double initial, the initial amount, okay? An owner. So when someone call a checking, when someone call to create a check account, so if someone wants to provide the initial amount and also want to provide the owner, right? So which is string. Okay. Now we can say, can I say owner? Let's say, because we assume to inherit the variables in the bank account, right? So in the bank account, we have balance account owner. Okay, balance account owner. So can we say balance equals init amount? Sounds like reasonable because we're supposed to inherit the field variable of the bank account because checking account is actually is a derived class, but we know that this is not going to be working. That's something we're going to talk about later. The reason for this is because the balance is defined as private for the superclass or for the base class. Now, if something is defined as a private for the base class, the derived class cannot directly call it. So you cannot say balance. It will be a mistake to have a balance. Okay. And how can we resolve this? We'll know that. But at this moment, I don't want to do this. What I want to do is, for the check and count constructor, I should be able to call the constructor of the superclass, the constructor of the base class. Okay. Now what I do is I can use a particular term because I cannot say bank account. I can say bank account and then we're going to say init so I just put init account and also put the owner. Okay. Can I do this? Maybe. But in Java, there's a special term if you want to call the constructor of a superclass. I use super. Okay. Now, when we use a super dot init amount and owner, and this is gonna actually assign the init amount to the balance and owner to the account owner. Okay. Now, when I actually initialize when I create a constructor to create a checking account, I also, because checking account has its own variable, right? Transaction count. So which actually does not exist for the base class, but it's actually in the checking count. So I need to set up the transaction count, right? Okay. So the transaction count should be free. I should have put 2. The transaction count should be 0 initially, right? And every time when we deposit it, and the transaction count is going to be incremented by 1. Every time when we withdraw a money, we can count a transaction count. We can add a increment the transaction count, but initially transaction count is 0. So once you create a checking count, so I call the superclass constructor to do this, and then transaction count set to 0. So that means I have a 0 transaction count. So that's the special about the constructor for the checking count. The checking count set up not just the balance and the account owner. Checking account in the constructor also set up a transaction count, which is actually a special field variable for checking account, not for the general bank account. Okay. Now we can also define the other constructor. For example, general. Can define a default constructor. So default constructor, what are you going to put in here? When I call the super, I can just call the default constructor Okay. I just call the default constructor of the base class, right? I call the constructor of base class. Then there's another constructor in the base class that only provides the owner information, right? So in that case, I call a class which only contains one. Yeah, I just actually call this the bank account class which only provide owner. Okay. So I defined 3 constructors. Okay. Now, if I do this and without defining any additional methods, then I can directly use the methods, the member method defined in the base class. Okay. However, I find out the deposit, if I call the deposit for checking account, it will call the superclass deposit, which is the deposit defined in the bank account. Now the bank account deposit only actually change the balance, right? Just add the amount to the existing balance. But that deposit does not update the transaction count, right? Because transaction count only works for the checking account. So that means I have to define my own deposit. Okay, I have to define my own deposit. So let's say public okay void deposit amount. Now you may ask, now we have a deposit method in the base class. Now if I define the deposit method here, use the same name, does that work? Now this is going to working. And in this case, we called overrider. Okay. Okay. So if in the derived class, we have a method which has the same name as the superclass, that's called overrider. Okay. This might be confusing because we actually discussed the case like in the same class, we can have 2 different methods with the same name, right? And what is this called? If we have 2 methods with the same name in a class, we call it overloading, right? Overloading. But here, if it's across the class, we call it overriding. Okay. Okay. Now, so the deposit here, what we should do is, okay, so we can deposit money, we can actually add a transaction, right? We can add a transaction over here. Okay, let's see. Okay, let's see. I accidentally clicked the key, so. Okay, I'm back. So when we define the deposit, okay, now we first need to change the balance, right? Okay, so we need to change the balance. We hope we can change the balance by calling the superclass deposit. Okay, so there's a deposit defined in bank account. Bank account is the base class now. It's a superclass now. So we hope that we can call the superclass, and we call the super dot deposit. And in that case, then we actually call the deposit in the bank account class, and we put the amount in there. Okay. Now this way, we're gonna actually. So what's the deposit in the superclass? Let's see. The deposit in the superclass basically just to change the balance, right? So we add a deposit amount to the balance. Okay, so we add a deposit amount to the balance. However, the deposit, the overridden method in the checking account, we not just actually deposit the money and change the balance. We also going to change the transaction count. Okay, so the transaction count going to be incremented. So we put the transaction count plus plus. That means transaction count equals transaction count plus 1. That defines the deposit. And the same thing for the withdrawal, right? So if we define the withdrawal, okay, and then we're going to say superclass withdrawal and also withdraw amount. Sorry. And also withdraw amount. And then for withdrawal, I also increment the transaction count. So the transaction count is always going to increment. Every action I take for the checking account, I always, increment the transaction count. Okay. Now for checking account, I may actually, the bank may charge the owner some fee if the transaction count reaches the limitation. Okay, so I can define a public method called a deduct fee. So I basically add a method. Okay. This method is only in the checking account, not in the bank account. The bank account may not have the deduct fee because there's no such a thing as a transaction count, right? So if transaction count is greater than free transaction, number of free transactions. What is a free transaction? I think it's 5, right? I define as a 5. If it's greater than 3 transactions, and then I'm going to charge fees. Okay. So it's a transaction fee. I think it's a $5 times the transaction count. Transaction count minus free transaction. Free transactions, which is 5. So that means the transaction count is more than 5, then if transaction count is 7, for example, then 7 minus 5, which is 5 is the number of free transactions. Now you got a 2. And for these 2 transactions, I need to charge the fee. Now what's the fee? It's a transaction fee, which is $5, which is defined up there. Transaction fee, right? So that's something I want to do, right? Okay. Now, when the bank actually charges your fee, then where's that fee coming from? So you're gonna actually withdraw, right? The bank gonna automatically withdraw the fees, which is the amount that exceed the free transactions. The bank gonna periodically call the deduct fees. Like every month, the bank is gonna check whether you actually reach the limitation. If you reach the limitation, I'm gonna actually deduct the transaction fees. Okay. Oh, I'm sorry. The super withdrawal should be inside here. If the transaction count is greater than the free transactions. Okay. Now, once I actually charge the deduction fees, that means I clean up everything. So what are you going to do? What's the transaction? What's the free transactions again? I'm going to reset the transaction count back to 0. So at any period, so I check the total transactions. The total transaction is more than 5, then I actually charge the transaction fees, and I reset the transaction count back to 0. Okay. Okay. So looks like this is the only additional method. Now the other methods, deposit, withdraw, I'm gonna redefine this deposit with a minor change. So I still do the same deposit as the base class, but I add the transaction count in my deposit, right? So let's actually do this, and let's actually compile it. It's kind of slow. Well, it's working. So then I can, in the main method, I can actually, well, I can create another bank account, but this time I gotta say checking account. My checking. I put my first initial amount of 1,000. Name is Brady. I already used the Brady for my checking by checking account. It's a different checking account, so I call different name. So let's say Mary. Okay. Okay. I think this gonna work. So I created my checking. So then I can just do in the last one, I'm gonna call system out. I just my checking. That's the net and get account owner. Okay. So let me actually comment everything else out so we can clearly see what's actually printed out. I just comment this piece out. So let's compile it again. So what's going on? My checking. Oh, I think I just defined it wrong. I think it should be checking. Okay. The check account, not a check account, checking account. So let's do this. Compile it again. Huh. Still have some error message. Expect a public checking account owner. $17. Okay. Checking account.java. Checking account.java owner. Checking account. Super owner transaction. $18. Call default constructor. Cannot find check account owner. Okay, let's see. Oh, sorry. I should actually, when I define the method, I should put the method type, account the owner. Yeah. Okay. So now this is always typical. When you try to compile it, you're always going to experience an error. That's okay. I have few 27 public void withdraw double in the checking account cannot override a withdraw double in the bank account. Okay. Okay, there's another one. 27, 34. 34 is another problem. Double transaction fee. Free transactions. So fee equals transaction fee. Let me actually copy paste. Transaction fee, transaction count minus free transactions. Okay. Free. Oh, I think I missed the A over here. So let's try again. We may still have a problem with the withdraw. Let's see. Okay, there's one more error. So super. Void. So let's see. Withdraw double in the checking account cannot override a withdraw double in the bank account. Public void. Withdraw double account. Oh, okay. I think the withdraw has a boolean. Okay. Okay. Now I see. If you want to override, you have to make sure it's exactly the same as the base class. Okay, now this should be working. Oh. Checking kind of 30. Okay. should put the super over here and the return. Here we go. Now let's execute it to see what we print out. So Mary Lou account, Mary Lou, that's account. So Mary Lou account, it's a my checking get account owner. So Mary Lou account is owner is, I put this, let's see. Yeah, Mary Lou account owner is Mary Lou. So this way I can define a derived class, and then you can check also you can check the balance. Check the balance. So let's see whether there's a get balance. Yeah, get balance. Okay. So let's see. So Mary Lou's account owner is Mary Lou. Mary Lou account owner is, okay. It should be balance should be Mary Lou account balance is this. Now, if we, put the deposit here, so my checking dot deposit, and I add 2,000 here. So if I actually call deposit, my checking dot deposit, that deposit I can actually use the deposit defined in the derived class, right? So this is going to override the bank account deposit. The only difference is that you can actually, yeah. So Mary Lou account balance is 3,000. So when I open the account, it's 1,000. When I add a deposit 2,000, so that's 2,000 plus 1,000, that's 3,000. So basically I can define a derived class. And in the derived class, I don't have to reinvent the wheel, right? So everything actually already defined in the bank account should not be defined in the derived class. The derived class only include the necessary field variables. So that's basically the derived class. Okay, so that's the example of bank account. So I'm gonna leave the checking account for you. Hopefully you can actually implement the checking account. Okay, so I'm actually going to post both the bank account, the savings account, checking account, and savings account on the Blackboard. But you can work on the savings account. I'm sorry, not checking account. Checking, you can say savings account as a derived class, and you would define the interest rate. So now with derived class, the access by members of derived class. So the members of the derived class have access to the public member of the base class. So everything defined in the base class can be accessed by member class. The member class can call any methods defined in the base class as if this is the own, as if it's its own class, okay, own class method. But the derived class cannot access the private member of the base class. Unfortunately, if it's defined as a private in the base class, you cannot access it. Okay, but if in any method defined as a public member, then the derived class can use them as their own. Okay. So here are the some of the specify the keyword used. A private. If there's a private, basically it means it's only accessible by itself, by the class itself. Now, public means accessible by self, derived class, and elsewhere. And sometimes a method has no specifier. That means it's either not public nor private. That means it's only accessible by itself and the other class in the same package. Now, we haven't talked much about the package yet. Package basically means every class defined in the same folder. Every class defined in the same folder. That's the class. These are the class in the package. Now, Java allow us to also introduce another keyword called protected. Okay. As I mentioned that in the derived class, I cannot directly call balance because balance is defined in the base class, but it's a private member. So if you want to access the balance, you have to call get balance. Call the get balance because get balance is defined as a public method in the superclass, in the base class. So if I call get balance in the derived class, it can access the balance. Okay. However, Java provides some kind of field. It's called protected. The protected basically means it's accessible by self, derived class, and the other class in the same package. So it's still protected. Other members of a class cannot access it, but the derived class can access it. That's called protected. Okay, that's something we're gonna actually talk about later. So now in this definition, we use the concept called overriding. Okay. So overriding basically when a derived class defines a member method. Okay. When a derived class defines a member method. Okay. So then if the member method has the same name and the parameters as the base class method, that member method is said to override the base class method. Just like a deposit in the derived class or withdraw in the derived class. These deposit and the withdraw in the checking account class basically override the deposit and the withdraw in the base class. Okay, that's something we're going to continue to talk about on Friday. I think that's pretty much all for today. Do you have any questions? Okay. I think that's pretty much all for today. Let me